That is what FACETs is all about, and also looking at a framework for progress, and I'll describe a little bit of primordial soup a little bit later. So if you walk away with nothing else, you have kind of two things that FACETs represent. It is that new watch warning paradigm, and it also represents a framework for moving forward to sort of organize and strategize, if you will, what we might be doing in the future for warnings and watches. So I have to start with this huge disclaimer that the National Weather Service has not agreed to this or signed on and said this is exactly what we're going to do, because it is fully in exploratory mode right now. It's under development at NSSL, but we are doing it in lockstep with the National Weather Service to make sure that it does meet the needs for the public. So many of you have seen me do this presentation before. I usually start with this as a quiz, but I'm going to jump right to the answer of this one. So the question is this a tornado warning in 2013? No, actually this is a tornado warning that was issued in 1971. And my point in showing this slide is that we have really not changed our warning methodologies in over 40 years. Yes, we've changed the formats. Yes, we've gone to storm-based or polygon warnings that we issue nowadays. But the underlying methodologies of a deterministic type warning product, either it's binary, you're either in it or you're not, that concept has not changed much in over 40 years. And I think just by looking at what the world was like in 1971 with some of those images there, you see that society has changed dramatically in those 40 years, and it's probably time for us to take a look at how we do our warnings and watches. So the challenges, I'm going to sort of dive into some of the current watch and warning system challenges. As you see here on the imagery, the polygons that we are issuing now are usually aimed at a multi-phenomenon, and if we issue a tornado warning, we still have to handle hail and strong winds. So the area impacted by a tornado is actually much smaller than the polygon itself. And what we've done is added up an average year, add up all the area of tornado warnings. What you see in red there is just a summation, depiction of the summation of a tornado warning area issued in a particular year, and this is actually a 5-year average. So the red represents the area summed up of all tornado warnings issued in a particular year. The yellow, however, is the area actually impacted by tornadoes. And for me, when I saw this chart, and courtesy of Greg Carbon did it first and Patrick Marsh ran the numbers again for me, it just screams a perceived false alarm issue for us in the country as we issue these warnings. And then when we issue polygons that look something like this, it really is a complicating factor. I always refer to the poor folks in Sebastian, Texas, trying to figure out what the heck is going on when they're on the boundaries and they're surrounded by polygons as being a deterministic approach. So while polygons were an advance for us moving forward out of just purely text-based information, they are still a blunt instrument for communicating this dynamic, small-scale, and multi-phenomenon threat. We also have another challenge in that we have what I refer to as the time-space continuum. If you look at on the right-hand side here, the event itself can be not only tornadoes, but hail, winter, fire weather, but we have an event here that occurs somewhere in the time-space continuum. And our normal way of operating in the Weather Service is that we issue these outlooks days in advance for more on a larger scale. We get in closer to the event, the watches get issued, and as the event unfolds, then the warnings begin. And I submit that this is a rather product-centric and deterministic approach, and I even use the word presumptuous, and I use that a little bit cautiously. I'm not trying to offend our warning forecasters out there, but when you really stand back and look at it, the act of issuing a tornado warning or any type of warning is somewhat of a presumptuous act, as if we know what's best for the end user and when they should get information for them to make their decisions. And so what we're trying to do with FACETs is resolve that or reconcile that, that act in some ways to help the end user make better decisions. We also find that in between these products that get issued, there are information voids where there is information needed. Emergency managers or hospital administrators and such need to have additional information, And there's information available, but maybe not by the same mechanism by which Weather Service forecasters typically put out these products. Yes, we have NWS Chat. Yes, we have other ways of GraphiCasts and other ways to get the information out, but they are sort of scattered all over the place. It's not a part of a continuous flow of information from in the same medium. So there are some challenges that we have with the existing system, and there are many more that we could probably identify, but in the interest of time, those are probably the two or the bigger ones right now. So the question that Weather Ready Nation really kind of triggered in our researchers' minds here is that should we continue addressing these challenges in this ad hoc piecemeal manner, what I call tinkering? Should we continue tinkering with the existing system, or is it better to maybe take a step back and look at a whole new watch warning paradigm that addresses those challenges comprehensively in a way that we refer to as reinventing the existing system? And I think the answer is probably a little bit of both, but if we tinker towards something that is not really reinvention in the long haul, then all we are doing is tinkering and maybe not getting the best benefit out of the reinvention. So if we're going to shift the paradigm, we're going to shift to a new watch and warning paradigm, and we need to look at the things first we need to look at the good things we do now. In some ways we say first do no harm. Don't throw out the good stuff that works right now. Got to keep that stuff in place. Then we look at the challenges. I mentioned a couple already, but take those challenges and refine and revise or reinvent those challenges. And through Weather Ready Nation, that really stimulated some of those thoughts. Well, one other thing that we're looking at here as well, when you stand back and look at reinventing and new paradigms, take a look at the trajectories, where things are headed, both in science and in society, and the tools we use as well. So we have to look at where we're headed, and I'm going to spend a little bit of time on this one as well. So if you stand back and take a look at the trajectories, what I refer to as the trajectories of science, society, and technology, one of them clearly is the storm scale models. NSSL is heavily involved in doing developmental work for Warn on Forecast, the storm scale ensemble types of things, types of models that are coming along, and at some point when we get computational capacity, they're going to be a very powerful tool for the warning forecaster. Another place where we see the trajectory is the grid, and already starting to play on those things through NextGen and other things that the aviation community has asked us to look into, but Weather Service and DoD and others are looking at getting us onto the grid. And for all practical purposes, we are already on the grid on the National Weather Service side in our GFE and NDFD databases, but our severe weather operations are not on the grid yet, and that's sort of a point here that we want to take a look at. FEE, by the way, is probabilistic hazard information. I'm going to cover that in just a bit. Another trajectory is the influence of social and behavioral sciences. I think we meteorologists have started to figure it out that there's only so much we can do on the science, the physical science side of the house. We do need to bring in the social and behavioral sciences, so that's another important trajectory that's taking place. And we have the perennial question about, watches and warnings. Are there alternatives to using those two words? Are there different ways to communicate threat? And we look to the Canada and European countries that are starting to use these kind of concepts, and I'm going to bring that in a little bit later. And then another trajectory we have is just an exploration-friendly environment where we have test beds and proving grounds, a rich, fertile ground for ideas to take root, sandboxes, if you will, where some of these ideas can be tested out. So I look at all this, not only the challenges, but the trajectories that we're seeing here as an opportunity to develop a new threat forecasting paradigm. And we try to hold it to these 6 criteria. We modernize it, make it effective, still scientifically robust, and such. So there are some things that we want to look at. And notice I didn't say a watch warning paradigm. It's a threat forecasting paradigm that moves away from the deterministic type of approach to something else. So here it is. It's for any of you that hate acronyms out there, I apologize, but it really needed to have a name. So we dubbed it Forecasting a Continuum of Environmental Threats. And the panels you see across the bottom there are the 7 facets of FACETs, if you will. And if you take from left to right, you really kind of notice that they follow the flow of what most people understand as the warning process. You start with your methodology. What is the nature of the warnings themselves? And you work your way all the way through the process to the very end at verification. So it's designed and set up to model the warning process, and then stepping through each one of those to ensure that the tools and resources are there and the science is there to back it all up. So I guess another way to say that is if you're going to tinker at one point, you have to realize that there's going to be a downstream effect. So what we're really looking at doing here is a holistic approach to the watch and warning paradigm, and adjusting it, tinkering it as needed, but it's going to have a downstream effect to make a holistic change. So we're going to start one step through each one of these facets, and the first one is the grid-based probabilistic threats. This is the method. Facet number one is the method or nature of watches and warnings. The way we do it now is through deterministic, or these binary text-based messages created from polygons. That's the nature of the watches and warnings that we issue today. In the facets paradigm, however, we go to grid-based probabilistic threats. And as soon as I say probabilities for the public, I usually get that response. So I just ask people sort of keep calm, and there are ways for us to communicate this. In fact, we do probabilistic information in a non-numeric way quite often. We are good at doing that. So I am not going to be sitting here proposing that we send probabilities of tornadoes out to everybody. There are other ways to communicate that sense of probability without using a number. So if that's your concern, I would say set it aside for the moment and just sort of allow me to carry on. So we begin in facet number one with something we call PHI, or probabilistic hazard information. This is a way to communicate a certain probability of a threat in a particular location. And you see in the imagery here, on the figure that I've got here, this is an example, a mock-up of a 30-minute threat for tornado probabilities in a certain resolution. Right now we're sort of aiming at 1 kilometer resolution. This is a little coarser than that. And I know folks who know their statistics would look at those numbers and say, that's outrageous, you would never have your probabilities that high. I get that, but I just want to sort of demonstrate what that probabilistic hazard information might look like on a grid as compared to the polygon that gets issued in a typical tornado warning. And you see, even in that polygon, there are areas for tornado probability that the probabilities are very low, even if non-existent in that. So it kind of gives you a representation of the finer scale and the detail that might be coming out of these grids, or the probabilistic hazard information. So the forecasters will convey that threat probability on the grids, and notice it's not explicitly a watch or a warning that they will be issuing. They will forecast and communicate through those grids. Well, what that does, though, is that sets up the chance to still use legacy products. Watches and warnings are still going to be issued and can still be issued, but they're going to be at some predetermined threshold. In the example I show here, I just arbitrarily chose 60%. We can argue all we want what that probability ought to be, but for demonstration purposes here, I just look at 60% as the threshold, and your tornado warning falls out of the grids for that in a much more precise area and focused on that in that area. What this also does is opens up the door for new products or new messages. If your threshold for severe or for impact is much lower, if you have a lower risk tolerance, you could set your own threshold for where you take action. So let's say your concern is at 30% risk, 30% probability. You could act before the warning officially gets issued. And we hear time and time again about those who have lower risk tolerance, like hospitals and baseball fields and these other things. They would like to know before the warning gets issued, what's the relative threat? Is it increasing? Do I need to know what to do, or can I do something before the warning gets issued? So the intent behind facets is to deliver that sort of information pre-legacy warning. Again, I want to stress this is not just for severe storms. This can be for any environmental threat, which is why the ET in FACETs is environmental threats. It's designed to be all-encompassing. So let's look at the FACETs continua, plural of continuum. First of all, we have a temporal continuum from days down to seconds that we're going to follow. I'm going to show this little animation here, but basically to demonstrate the different continua that we're talking about when we refer to the C in FACETs. It's also a spatial continuum from regional down to local, U.S. CONUS, if you will, down to small scale. Phenomenological, all threats, not just tornadoes, so it's not just focused on that. And there's also other continua that we can be looking at, the impacts. They can be from minor to catastrophic on that continuum. Technologies that are legacy to modern continuum. Sophistication from simple, just tell me if I need if I've got a warning or not, to more advanced users who might want to mine the data out of the information. So there's a continuum of sophistication there. And there's just also a continuum of products that might be issued from outlooks down to warnings. So let me run through this loop to sort of demonstrate this. And you see the timer clicking off in the upper left-hand corner. We sort of do this already, but this is the whole point of this is that it's a probability of tornadoes, and as the day of the event approaches, you get more and more refined with your information, down to the point where the local probabilistic information starts to kick in. So you can see almost in this sort of scale here, this is where the SPC is fully operational, handing the probabilities down scale to the local office when the storms start to kick off or pre-convection, then they start using their tools, the radar and other things, to communicate at a higher resolution and the higher probabilities for a particular storm. So within this imagery here, you see all sorts of continua of the FACETs approach. So from that, once you have a database that does sort of thing, you can extract information. Now, I arbitrarily chose 4701 North Porter, the place I was staying when I first moved back to Norman. And from the database, then, you can extract information about the relative probabilities, or the relative risk, if you will, of tornadoes, flooding, hail. Pick your phenomenon, and you can see this on a mediogram sort of displayed this way. And again, by going grid-based probabilistic hazard information, it opens the door for lots of different ways to mine the data and display the data. I'm just going to show you a couple examples. As we get closer in time toward the event itself, then we get on a different time scale here of hours and minutes even, and you can see the relative threat for the particular phenomenon at a specific location, or within what we're looking at here is a 1 kilometer resolution. So again, mining the data out of there is very important. So what I'd like to do is just sort of show this example from the Moore tornado from last year of when the warnings got issued and how they are issued as a product-centric deterministic warnings. And that's the way we do things now. But I ask, with the FACETs approach, don't think about that deterministic approach, but think more of a continuous flow of relevant, actionable information. And so what you see here is sort of this little plume that gets updated once every minute or every 2 minutes, and it's continuously feeding that information to end users. So as you see from this example, the probability of tornadoes are going up in that threatened area before the warning gets issued, and at some point a threshold gets passed and the forecaster issues their deterministic warning. But in the FACETs era, you would be able to communicate those increasing probabilities at specific locations throughout the course of the event, well before the legacy warnings get issued, allowing other people to make their decisions more earlier and with a little bit more precision. Those are the sort of the notions here that we're working on. All right, that was facet number one. I'm going to kind of fly through the next few facets. Number two is the observation and guidance. This is a big bucket. This is what the forecasters use to make their decisions. All the tools, radar, satellite, models, observations, and everything. And there are some things coming down the line that are very important for the era of facets and the things that we're doing with FEE. First of all, I mentioned these earlier, the storm scale numerical weather prediction or ensembles. The warn on forecast is one example that we're doing here. But the question we ask sort of, once we get that numerical model output, then what? Okay, so we get this probability of vorticity field. What are we going to do with that? Are we going to turn that into all caps text-based information, draw a polygon around that, and still use the same 1970s type of approach to this, or is there something else we can do? And that's where FACETs comes in. We look at the FACETs approach as being the delivery mechanism for warn-on forecast generated probabilistic output. And I'll show some more examples of this here in just a bit. In fact, I will do right now. One of the things that we were discovering with or warn-on forecast modeling is that it improves with things like our phased array radar, the rapid update information from phased array radar every 40 seconds to a minute or so. Get that information assimilated into the model, and the model itself, the ensemble on warn-on forecast, behaves much better, and we get better results. And so what we do with that, for example, so out of warn-on forecast, we might get this plume, if you will, of the rotational potential in a storm in a probabilistic sense. Where's the probabilities greatest for rotation in this particular storm? And then we can do some smoothing from the ensembles to get a mean pathway, and from that we then drill down deeper and start getting actual probabilities at specific locations. And then once you have those probabilities at specific locations, you can do things like mining the data out of there, clicking on a particular cell, and here's your probability of a tornado at in a specific time. And we can ask questions like, when will it get here? How bad will it be? All of this from a probabilistic database approach. The facet number 3 is the forecaster, and we cannot leave that person out of this mix here, because it's the person that makes the decisions, and it's the knowledge and skills and abilities of that person that are going into what actually goes out the door from this guidance and observation. So the human brain, or the wetware, is a key part of this. It is forecasters over the grids, and as I say, they're as essential as ever to the entire watch and warning process. The reason I'm harping on this so much is because this is a whole new paradigm, and it's going to require a whole bunch of new training on data management, probabilistic threat information, uncertainty conveyance, and you see all the things here. So please understand that we know going into this that there's going to have to be a major effort put forth to train the forecasters and make them even better in communicating that information and threat information than they are now. So facet number 4 are the tools. So once the forecaster makes the decision, that's great, but what kind of tools they have in place to make it as seamless and streamlined as possible to get that grid-based information out. So we are looking at the hardware and software. In fact, through OAR, we have gotten some funding to start playing around and developing some prototype ideas for how that might get done. Chris Karstens from SIMS and NSSL here has done a fantastic job of developing this little tool here. This should look very similar to the hazard services type of tool that GSD is working on for future AWIPS interactions. Right now they are working more on the hydro side, so we are starting working on the severe convective side for how how the widgets and the tools that might be useful to the forecasters to deliver this kind of information. And in fact, next week we'll be having our first hazardous weather testbed experiment, testing these tools for the very first time, with forecasters coming in here and giving us feedback on what works and what doesn't. So we are looking at that facet number 4 as threat grid tools as a major component of what we're doing. Facet number 5, well, it's all great if the forecaster can have the tools to put them out the door, but if the end user doesn't have anything useful, then what have we done? So we're looking at the graphical, textual, auditory, whatever the end user might see or hear as an important component of the entire facets paradigm. So let's start with this. Yes, there will still be watches and warnings falling out of the grids. They may be smaller and more phenomenon specific. So there may be a tornado warning, there may be a hail warning, a lightning warning. Pick your phenomenon, and we can get very complicated or very simple depending on what we decide to do in communicating that. As I mentioned earlier, this will allow user specifiable thresholds. So again, we're aiming for the useful output that forecasters might, that end users might gain from that. We also, by having non-deterministic type information flowing out, it sort of changes the whole notion of what a warning is. If an end user decides to take action at a specific time, do we call them warned on that? Well, maybe so, and that would sort of open up this thing for a longer lead time. If they have the advanced notification before the official deterministic warning is issued, they take action and take action earlier and then get that longer lead time. In this whole FACETs approach, we see tremendous opportunities for the private sector to mine the data, to turn it into some things. I'm going to show a couple of examples of how the private sector might capitalize on that. And then this opens up the door also for more impact-focused type information. And I don't have necessarily the time to go through all of those, but suffice it to say that there are additional ways to communicate things like urgency, confidence, range of possibilities, and things, again, that are very difficult to do with a deterministic polygon approach, but through grid-based probabilities, it opens the door for those types of things. So an example of useful output, again, I'm going to turn to what they do in Canada and in Europe by taking maybe a different approach to our messaging, that it's not just watch or warning, but it turns into something that is a more color scale, yellow alert for something, and more importantly, what you do when that phenomena, or when that level is reached. Red alert for tornadoes, or red alert for hail, and some things such as that. Canada and Europe are already going down that road, and I think what we're seeing is a lot of social science pointing us in this direction, but are we sure? So that's one of the questions we have. I'll cover that in a minute about how social science might come into this. So what I'm about to show you is just a really kind of I always call it a goofy mock-up here of what a future tornado weather radio might look like, a future weather radio screen. If you do a color screen with LEDs on the side, or maybe little poles around the neighborhood that have color things that gather their information through weather radio to indicate the relative threat in the area. And you could foresee something like this. And again, this is kind of kludgy put together, but I think it demonstrates the point. Now, I don't know if your audio is going to work so well on this, but we're going to see an example here of two different locations within a forecast area. Again, this is the Moore tornado, but we're going to look at maybe two different users from their vantage point as to what their relative threats might be for tornadoes as we step through this, this little example. Again, I don't know if the audio is going to work on this so well. Maybe you can hear it in my phone. So at that location, you see the relative threat increasing, and then as the storm, the tornado threat moves off to the north, the probabilities might go down. Normally, they would have been in a full tornado warning, and everybody taking shelter. Now, I absolutely get that the gradient is too tight on the south side, and our skill set might be not at that level yet, but it's sort of just to demonstrate the point. Now we're looking at more local into the in the path of the tornado itself, and you can see as the storm approaches, the threat meter, if you will, goes higher and higher, and people presumably will have taken shelter because we hardly ever see it that high, and maybe this is for me. This is something that I need to respond to. Okay, again, please forgive the real kind of crudeness of that example and the gradients being really tight on the edge of that. They will probably not be that tight for most situations, but it does kind of give you the idea of how you can mine the information out of the database. Mining the data also includes new phone apps and such. So what you see here, again, is for a specific location, what is the relative threat for a particular phenomenon in the next 30 minutes, 20 minutes, pick your time scale. So, and this is updated every 2 minutes or so, and so a little bit later on, boom, there comes the storm and wind and threat within the next 30 minutes. And if people are conditioned to this, they will realize that this is actually from my location, and that you start to calibrate society because they become used to this information for their location rather than for a larger area like a county or several counties, the way we issue our polygons now. So if we have this useful output, it still doesn't mean that it's going to work. And so what we have to look at is the effective response, what the end user does. And this is where the science and human interface come into play. And in my own opinion here, it's the most important facet because it's where social and behavioral sciences pay off. It's that interface between the physical and the human sciences that we have to address. I love how Jeff Lazo put it, and this is not published anywhere. He was just talking to me one day, and I said, I love that. I need to quote you on that. Basically, he's saying we have to learn how people respond to weather threats and accept the way they respond, whether that's logical or rational or not, and then build the system to work within that reality and still achieve the desired outcomes. So one of the ways we look at this is by looking at the bottom track you see here where it says forecaster. This is the FACETs approach. This is where the forecasters do their business and create their information and shove the output out the door. At some point you expect the proper response by the end users, but keep in mind they're operating on their own track as well. It starts with education and whether they're prepared and what kind of awareness they have, and then the response is an important component as well. So we sort of intersect here between the forecaster's path and the public path. And in that intersection is where we want to make sure that things are working. But what we look at for social and behavioral sciences is that it's not just right there. If we're going to do this right, we're going to integrate social and behavioral sciences throughout the entire process, the right type of discipline at the right step of the process. And we've already started doing that in some of our development work here. We've got human factors people working with us on the tools that we are designing to make sure that they are the best possible tools for forecasters. I just threw a bunch of examples of disciplines that should be or could be applied here, and we are working through Weather Ready Nation and some of the things planned coming up here to try to employ these various disciplines to the greater good of the entire warning forecast process. So I kind of refer to this as the FACETs epoxy. When you integrate social, behavior, and physical sciences all together, you're going to have a much stronger system as the end result of it. And then the final facet is verification, basically looking at how we've done. And I want to stress this. This is much more than just the forecast skill, which is what all us forecasters have been used to for a long time. We also need to measure the response on a regular and routine basis. We tend to measure the response during service assessments. When a major event happens and the service assessment team goes out there and does their job, we measure the response. But we need to do a better job of that, have that a part of our routine measures just to see if we are doing things effectively. Yes, we'll still have the numerical and statistical ways to do this for the forecast skill, but we also have to measure the response. One of the advantages of this verification method, or this grid-based probabilistic approach, is that our measurement and our forecast will be on the same geospatial grid. We don't necessarily do that now, but when you have that on the same geospatial grid, you can start looking at things like Brier scores and forecast lead time and all these kind of things that are a little harder to do in a deterministic world. So if we stand back, and I know I've pumped a lot at you here, there's a lot to be discussed. This is probably an hour-and-a-half presentation. I've tried to cram in about 40 minutes. The benefits that we have expecting out of FACETs is sort of integrating across the continuum here. We have information moving through the entire continuum, updated from days down to seconds for all threat forecasts. What we hope to do is to reduce that false alarm area by at least 30%, if not more than that. I fully expect that false alarm area, that red area that I showed earlier, is kind of pink here, to be reduced significantly by going the FACETs approach. We also have a warn on forecast delivery mechanism. So we get this great tool called warn on forecast, the ensemble predictive storm scale information. What do we do with that? So intent here is to have a better delivery mechanism for that type of information. And by doing this, we hope to identify many of the issues that Weather Ready Nation has identified, these vital conversation meetings that we had. Lots of different action items and such were identified. And instead of addressing them through tinkering, we actually take a holistic and reinventing look at the watch warning process. Also see lots of private sector opportunities in mining the data and doing really wonderful things with it, with those data. and then ultimately more actionable and useful information for the end user. So, in summary, the FACETs is this new watch warning paradigm, starting with grid-based threats and then working outward from there. It's also this framework intended to organize and guide reinvention efforts. This is what I referred to earlier, right out of my first slide about the primordial soup. We have a tendency to have lots of projects going on, and not only in the Weather Service, but in OAR. What we're trying to do here is give sort of a broader vision of where we're going, and so that those types of projects can still take place, but if they're aimed at the same thing, at the same end goal or same vision, maybe we can organize some of those efforts. I know that Pleasant Hill and Tulsa and the southeastern United States, some of the WFOs down there have experimented with these kind of things. All great ideas, all things that need to be considered as we move forward, but let's try to put these in a framework where we organize and guide those reinvention efforts to a more common and a better end that everybody can use. So ultimately, what FACETs is a means for improving and enhancing the Weather Service high-impact weather forecasting services. That's my motherhood and apple pie statement at the end. So there it is, folks, the various components of FACETs, but it all starts with that flashing oval there, the grid-based probabilistic threats, and then moving downstream from there, and then making sure that we integrate social and behavioral sciences throughout the entire process to strengthen the ideas and strengthen the concept. I know it's like taking a drink from a fire hose. If you're ever wanting to get more detailed information, I'd be glad to do a webinar or something for any of you for your offices or in any way necessary to sort of fill in the gaps. And I know I don't have much time left for questions, but I will open it up at this point to do that. So, Steve, let me know what I need to do.
Lance, thank you very much. Excellent presentation. You've added a lot more content since the last time I saw this, and I'm sure everyone has picked up on that. So I want to first remind everyone to queue up your questions. John Chattel is standing by, so use the raise your hand feature or submit one through the chat. But Lance, first I'd like to ask you one to kick this off. So you had the Jeff Laszlo quote up there, which I also agree is really on spot on with regard to what we would want to do. But looking out over the landscape, I'm not sure we are doing that. In other words, going to the users, starting to ask the questions to see how they behave, and then to design, or I guess in the case of redesign, perhaps the system we have. So maybe I'm wrong about that, but are you, that seems to be a, this is not a criticism, but it's just sort of the reality. We have a lot of, because we have a weather enterprise focused on improving tornado warnings, for example, we've been going at this for many, many years, many decades actually, but we haven't really been able to, let's put it that way, take the approach that Jeff Laszlo advocates. How do you respond to that?
Well, I think that's changing, and in fact, I know that it's changing. I was just going through some of the last AMS meetings, sitting in a lot of the social science findings and results. I am just fascinated by the fact that there are people who are not meteorologists who are asking these kind of questions and coming up with some really sound advice for how we might build those things in the future. I'm not saying we have all the answers yet, by no stretch do we have all the answers yet, but we're headed in the right direction, and there's some efforts being undertaken by NOAA and through Sea Grant and other things to start answering some of these questions. Storm-based impact-based warnings and the storm-based impact warnings research that Ken Galuppi and others are doing. They're starting to find some nuggets of gold that we can basically build the system around. But we need much more of that type of activity to really guide us.
Yeah, I'm aware of there are lots of activities and I think you point out to the primordial soup, they're relatively uncoordinated, and of course there's a lot of inertia built into our plans in NOAA to do warn-on forecast, etc. But I guess I would hope that maybe through FACETs we could start to more directly address those things in a systematic way, so that we get the social science folks talking to some of the other facets earlier on. I guess that would be my point.
Well, and that's exactly what we are doing with the whole facet structure. This summer, as Steve knows, we're going to be having a meeting here in Norman to start laying out what those pieces need to be, who needs to be involved at what step of the way. Lots of questions like that have to be answered, and we have to have the right discipline at the right place. So we intend, as part of the plan and moving forward, to make sure that those issues are addressed.
Very good. So, John Chattel, do we have questions from the audience?
Yes, Ed Mandel has one for us. Go ahead, Ed. Ed, you're unmuted.
I'm guessing it's going to be an AWIPS 2 question.
I tell you what, Ed, we're going to go ahead and go to Zoltan, and we'll be back to you in just a second. Zoltan, are you there? Uh-oh.
Well, this makes my life a lot easier.
All right, how about Tom Filiaggi? Are you there?
Can you hear me?
Yes, we can.
Okay, excellent. Lance, I've seen this before, and of your 7 elements, as I look at these, I can see how most of them could be done at some point, but there's one on that list that I think is harder than the rest, and that's verification methods. I think that would change things so much. When a lot of us look at these, they seem to make conceptual sense, and there's a lot of agreement. Oh, these are good things to do. We should do that. But at the end of the day, how do we show that it's working better than it did before? Can you say anything more about what kind of ideas have been floated around in regards to improving verification methods?
Yeah. Well, okay, a couple different levels to answer that. One of them is just at the WFO level, how we solicit the information and how we get that information and how we turn that into storm data, and some of these others that are still a little, have some room to grow and improve. So some of those methodologies are going to have to be looked at. One way is we're already using something called MPing to do some crowdsourcing, to be able to capture information in ways we've never captured before. We may have to change the rules a little bit, like using tornado debris signatures as verification for at least a proxy for ground truth verification. Tom, you asked this question, I think, last time when I was out at Boulder giving the presentation, and I grant you that there's a lot of questions here that need to be addressed, and it may require us reinventing some of our verification methodologies at the local level. Now, having said that, there are still some very strong aspects of when you have your measurement and your forecast on the same geospatial grid, as I mentioned earlier. You can do these things like Breyer scores and reliability and resolution, and really help inform back to the trainers, back to the process, as to where we need to apply our newer science and newer techniques. And I welcome suggestions or ideas on this. If I gave anything here an impression that we got it all figured out, then I've missed my mark. We have a lot of work to do, and I welcome suggestions and comments of how we tackle those particularly difficult ones.
John, do we have some other questions?
Yes, Albert Spencer. I've unmuted him. He has a question.
Shoot, that's you. Go ahead. Can you hear us? Can you hear us?
Yes, we can.
Yes, I can hear.
Yeah, this is Mike Farrow, MDL. We're here with Benji Spencer and a group of several of us here. Ed Mandel has made an appearance. So anyway, one of the questions we had was, I know that there is a major project with AWIPS 2 called Hazard Services, which is being worked by OAR, GSD, and Boulder in conjunction with Raytheon and the Ames Program Office. Have there been any connections made with this FACETs effort with what's being developed for hazard services?
Yeah, well, absolutely. In fact, that the funding that we got to work on the FACETs interface and the prototype, when we put the proposal together, we included funding for GSD to work with us on this. So, in fact, we meet and talk about every other week just to make sure we're on the same page. We've gone up to Boulder. We've got our developers and such. We've got our developers all working on the project together. So. Man, you all saw my calendar. So the answer is absolutely yes. We are working with GSD on developing this system together. And what I showed you in terms of the tool that Chris Carson has developed, he is developing it with the intention to be very similar to hazard services concept, and we're working together with him on it.
Okay, so one follow-up then would be, I know that the schedule for the hazard services delivery is fiscal year 2015. So about a year from now, they're going to try to be finishing up their effort prior to the current Raytheon contract ending. Can you tell me, is there any plan for some of these FACETs products that conceptual products that you laid out for us today, are any of those going to be part of the hazard services delivery a year from now, or is
no?
Okay.
No, we're a ways off from that. We're doing a prototype this spring in the hazardous weather testbed experiment, and later on we're going to have the hazard services included in the hazardous weather testbed. So we're going to get a good look at it there and have a chance to play with it a little bit. Next year we're hoping to have the prototype on AWIPS as a prototype in the hazardous weather testbed. So we're good 2, 3, 4 years out from seeing some of the stuff fielded, but we're trying to get the underlying plumbing done first.
Okay, thanks. That helps. Appreciate it.
Yeah, Mike, this is Steve Smith. So the Greg Stump from MDL is right in there with Lance and his team working with GSD. The thing we've been very careful about is not to get into the critical path of hazard services with the fee tool. So the fee tool is the thing that would link in here. So we're trying, but you know, we don't want to encumber the critical path of hazard services at this point.
Okay, thanks a lot. That wraps it up for me. I appreciate it. Anybody else in the room here? Okay, thanks.
All righty. Steve Goodman has a question, if I can relay it to Lance. He says, I understand from, I think it's Lance, we will demo the FACET framework at the HWT this spring. What does success look like? What metrics do we have to verify we are on the right track, and or lessons learned? Thanks.
Yeah, the metrics are quite simple here, and that is, are forecasters able to take probabilistic guidance from ensembles or from other sources, including satellite things? I keep forgetting to mention that in there. Sorry, Steve. But some of the probabilistic guidance and the success, the metric is going to be very simple in this. Are the forecasters able to manipulate the data and get out of it what they want in terms of probabilistic guidance? And we are going to be doing some more quantitative and objective measures of probabilities and whether the warning verified or the probabilities verified and such. What does success look like? I think it's going to be an indication of, okay, you need to fix this, you need to, this is good, this is not. We're not at the point yet to say, you know, tank the whole thing because it's never going to work. We still have a lot of prototyping to do here and building the interfaces and such. Good question, though, Steve. It's something that we need to have lined up for the out years.
All right. Zoltan Toth has a question.
Yes. Do you hear me?
Yes, I can.
Yeah. Okay. Thank you. Great talk, Lance. My question is about the loop that you showed. The probabilities changed from frame to frame associated for a tornadic event. If you know what image or loop I'm talking about, I saw 90% probabilities covering a relatively large area around the storm. So those probabilities, are they neighborhood probabilities or probabilities that actually the storm will be observed in any of the grid boxes?
So that's a big question that we're trying to figure out right now. Is probability of what? And there's lots of different ways to slice that. I think our early approach to this is going to be a probability of a tornado occurring within 5 kilometers, 10 kilometers, something like that. So that's probably going to be our first pass at this. We can get much more creative and more complicated, certainly, by going probability of what strength of tornado and these kind of things, but we're not ready for that yet. We just want to see what kind of basic skill set we have of probability of a tornado occurring within maybe 5 or 10 kilometers of a particular point. Did I answer your question, Zoltan?
Unmuted.
Yes, Lance, yes, you did answer, and I'd like to mention that with a student here who visited here a couple of summers, we looked at a similar question related to tropical storms. So we have some background with this as well, and I'd like to touch, talk more with you about this.
Right, and that's an important point to make on the whole FACETs approach, is that we are sort of data agnostic. We will take the guidance information from wherever we can get it, whether it's from an ensemble model like One Forecast, whether it's satellite prognostic information, even from other forecasters. I didn't show my slide here, but SPC is working with probabilistic outlook type of information. Hand that information downscale to the local forecaster and let them refine it with what they're seeing at the local scale. So the tools that we're envisioning here are not specific to just one type of input. We need to figure out how to be, how to capitalize on whatever input is out there.
Okay, John, do we have any more questions?
No, but we do have a comment. If we have a second, I can quickly read through it from Roland Nunez.
Go ahead.
He just wanted to say that at the CWSU, the gyra, or traffic light concept, is well received by our FAA customers. Our challenge is ensuring our customers are taking an effective response based on our output. And then I think he followed up by saying, I like this concept and I believe it has applicability to aviation decision support services.
Absolutely. I didn't even mention the whole aviation side of this. Again, it's intended and designed for application across the board. But then we're already talking with some of the FAA types from a research point of view. What can we do to sort of demonstrate the utility here? And yes, Roland, you will see. I sort of picked. It wasn't just me. We've all been taking a look at what's working out there. What kind of things are we seeing? And the gyro approach is not new. It's been out there for a while, and I know the aviation community's been using that through CWSUs, and that it's been working well, and we want to capitalize on that.
Okay, so can you hear me?
Yes, you broke up a little bit, but you're okay now.
All right, Lance, just to wrap up, I mentioned the Impacts Catalog project, which is underway, which is focused on user impacts for all sorts of weather phenomena, not just severe weather and convection. So that's another place where we will have obvious overlap and want to coordinate in the FACETs. In fact, it's sort of like taking FACETs to all scales and all types of weather phenomena. So. But anyway, I want to thank you for absolutely bang-up presentation per usual, and apologize to everyone for the technical challenges we had at the beginning. But we thank Lance, and if you haven't, obviously, if you have any other questions for him, just pick him up offline, and he's certainly more than willing to entertain those. And just a reminder, on coming up in May, we have Matt Davis. As the ITO up in La Crosse, Wisconsin, is going to give us an update on the IRIS project. That'll be at the May VLab
21st.
May
21st.
May 21st, yes. So thanks, everyone, and have a good afternoon.